This is Module 9, Section 3.5. We're going to look at forms of linear equations, and the two forms we're going to look at are the standard form, which we have looked at before, so it'll be review, and the slope-intercept form. We're also going to discuss graphing given slope-intercept form. Let's start with the standard form for an equation of a line. As discussed previously in Module 8, Section 3.2, the standard form for an equation in the form is ax plus by equals c, where a, b, and c are real numbers, and a and b cannot both be 0. The key to recognizing this form is the variables are on one side of the equal sign and the constant is on the other side. Note that the variable exponents are 1. So some examples of equations in standard form, and again the key is x and y are on one side and your constants on the other. 2x plus 3y equals 6 is considered standard form. In this book, 1/2 x minus 3/4 y is equal to 9 is standard form. X equals -4 is standard form. Note there that you're missing a y variable, but that's okay. That's still considered standard form. And y is equal to 1/4. You can also be missing the x variable. The new form for an equation of a line is slope-intercept form that we've not seen before. The slope-intercept form for an equation is y equals mx plus b, where m is the slope of the line and b represents the y-intercept of the graph of the line. The key to recognizing this form is the y variable is isolated on one side of the equal sign and everything else is on the other side. For example, given y equals -3x plus 5, the coefficient of the x term, which is -3, is the slope, and the +5 is the y-intercept of the graph. In ordered pair notation, the y-intercept is always 0, b, or in this specific example, 0, 5, because you know from previous sections that the y-intercept occurs on any graph where x is equal to 0. So b represents the y value, and x has to be 0 in order to be talking about the y-intercept. So again, to summarize, in y equals -3x plus 5, m is equal to -3, and the y-intercept, or the b value, is equal to 5, or in ordered pair form, 0, 5. So we're doing a direct comparison. Y equals mx plus b. Notice y corresponds with y, -3 corresponds with m, x of course corresponds with x, and then the plus b corresponds to plus 5. So m is equal to -3, b, or y-intercept, is equal to +5. Okay, so if we did these examples, find the slope and the y-intercept for the line y equals 5x minus 6. So rewrite your equation, y equals 5x minus 6, and ask yourself, is that equation in slope-intercept form? Is it in y equals mx plus b form? Because the only way you can glance at an equation and get the slope and the y-intercept is to look at the values listed out as such. So since this equation is in y equals mx plus b form, and the reason I know that is it's isolated the y, I can look at that value, and the slope is always the coefficient, or the number in front of the x, and the b value is always the constant that's on the same side as the x. You want to make sure you carry the sign. Okay? Another way to think about that is, since y equals mx plus b assumes addition in between the mx and the b, you can take a subtraction step and make it into addition if you want to change that to plus negative. Either way, you can see that the slope is equal to a +5 and b is equal to a -6, whether you just include the subtraction sign with it or whether you change it to plus negative and see that b is a -6. B, of course, is your y-intercept. And if the problem asks for ordered pair notation is always 0, comma b for your y-intercept. And so in this case, you'd have 0, comma -6 for your y-intercept. The next example says find the slope and the y-intercept of the line y equals -3/4 times x plus 2. Again, your first step is to ask yourself, is that equation in slope-intercept form? Is it solved for y? And the answer is yes. So you can do a direct comparison. Y equals mx plus b is the slope-intercept form. Slope is always the number that's attached to the x. So slope is equal to -3/4. And b is a positive 2. Carry the sign with it. b is a positive 2, which is the y-intercept, which in ordered pair form, if you'd like to write it in ordered pair form, would be 0, comma 2. That's your y-intercept. Okay, so let's do this problem. Write the equation of a line in slope-intercept form with a y-intercept of 7 and a slope of 5/7. Okay, so now this is kind of reverse of what we just did. You have to know that slope-intercept form is y equals mx plus b. In order to write an equation using that form, there are two things you need to know. You have to have something to put in for m, and you have to have something to put in for b. Note that the problem gives you those two things. They tell you your y-intercept is equal to 7. That is your b value. Okay? And you have a slope of 5/7. So you need an m and a b value. You have both of those. So plug those in for the m and the b in the standard form of slope-intercept form. And you get y equals 5/7 times x plus your y-intercept, which is 7. And there's your equation. Now, recognize that when you're getting an equation, you have to leave the x and the y in there because that's what you're trying to get. Next example, write the equation of the line in slope-intercept form with a y-intercept of 0, -4, and a slope of 6. Okay, much the same. You know that y equals mx plus b is the slope-intercept form. You need two things. You need something to plug in for m, and you need something to plug in for b. So this problem does tell you what the slope is. They tell you the slope is -6. And then the y-intercept here, they give you an ordered pair, which is fine. Okay, 0, -4. That's always 0, comma b. So b is -4. And plug those values in. You get y equals -6x plus b is -4. Or if you want to change that plus negative to subtraction, y equals -6x minus 4. Both of these say the same thing. Here I just changed adding a negative to subtraction. Okay, so can you use the slope-intercept form of an equation to get the equation of a line if given a slope and a point that is not the y-intercept? The answer to that is yes, or you can use the third form of an equation of a line called the point-slope form, which given a single point on your line, x1, y1, and knowing the slope, which is m, y minus y1 is equal to m times the quantity, x minus x1. So this is yet another way to get the equation of a straight line, especially if you're given the slope and one point on the line. So let's do this example. Find the equation of the line with a slope of 2 that passes through the point 1, -3. So here we're given the slope. Slope is 2, as the problem says, and we're given a single point, x1, y1, 1, -3. So if we know that y minus y1 is equal to the slope times the quantity x minus x1, if we put the slope in for the slope and our 1 in for our x1 and our negative 3 in for our y1, we'll have an equation of a line which we can then manipulate to put it in whatever form we want. So if we do that, we get y minus y1 is negative 3. That's equal to our slope, which is 2, times the quantity x minus x1 is 1. Now that is indeed the equation of the line, but you rarely see an equation left like that, so we're going to clean it up. I'm going to choose to put that final answer in slope-intercept form, so we're going to solve it for y. So here we've got y minus a negative 3 is the same as y plus 3. Double negative is a positive. And that's equal to, if we multiply that 2 throughout the group, 2 times x is 2x, minus 2 times 1 is 2. At that point, we're going to isolate the y, so subtract 3 from both sides to get it into slope-intercept form, simply because that's the form that's most often asked for. And we get y equals 2x minus 5 for our final simplified answer for a line that has a slope of 2 that passes through the point 1, negative 3. So let's look at another example. The top example says, find the equation of the line with a slope of 1/3 that passes through the point negative 6, 3. Again, we know our slope. Slope is 1/3. We have one point, x1, y1, that's negative 6 and 3. We know that y minus y1 is equal to m times the quantity x minus x1 will give us an equation given a slope and a point, which is exactly what we have here. So we've got y minus 3 is equal to 1/3 times x minus a negative 6. In our group here, minus a negative is the same as adding a positive. Double negative is a positive. So now we have y minus 3 is equal to, if we distribute our 1/3, 1/3 times x is 1/3 x, plus 1/3 times 6, or 6 over 1. If we clean that up, we now have y minus 3 is equal to 1/3 x, plus 1 times 6 is 6, 3 times 1 is 3, 6 divided by 3 simplifies down to give us 2. And then if we're interested in putting it in slope-intercept form, if we add 3 to both sides, I'm sorry, slope-intercept form. Y equals mx plus b, sorry. Y is equal to 1/3 x plus 5 as our final answer. All right, second example on this page, find the equation of the line with a slope of negative 3 that passes through the point negative 2, 4. Again, same type of thought process. We've got a single point, and we do know our slope, our m value. So y minus y1 is equal to m times the quantity x minus x1. That gives us y minus 4 is equal to negative 3 times x minus a negative 2. Here, minus a negative is the same as adding a positive. So we've got y minus 4 is equal to, if we distribute our negative 3, negative 3x, negative 3 times positive 2 is a minus 6. And finally, if we add 4 to both sides and bring it up here, we have isolated our y on the left-hand side. And on our right-hand side, we have negative 3x and minus 6 and plus 4 leaves us with a negative 2. Y equals negative 3x minus 2. And what if you were given only 2 points on the line? Can you use either the slope-intercept form or the point-slope form that we just talked about of the equation of a line to get an equation for that line? And the answer to that is yes. And since we are introducing the point-slope form, that's the form I'm going to choose to use to get the equation. So in order to use either form, you do need to know the slope. So remember, from earlier, slope is always equal to y2 minus y1 divided by x2 minus x1, the difference in the y values divided by the difference in the x values. Therefore, since you're given 2 points, let one of those points be x1, y1. Let the other point be x2, y2. It doesn't matter which point is which. Plug those values in as I have them labeled. Y2 minus y1 would be 6 minus 2. X2 minus x1 is 4 minus 1. 6 minus 2 is 4. 4 minus 1 is 3. And we now know our slope. Our slope is 4/3. Now to use the point slope form, y minus y1 is equal to m times the quantity x minus x1. You need the slope, which we have, and you need a single point, which we also have. In fact, we have 2 points. So the question then becomes, well, which point do you use to put in for x1, y1? And the answer is, it doesn't matter. You'll get the same equation either way. I'm going to use this first point only because I already have it labeled as x1, y1. So just for simplicity's sake, I'm going to use the first point. So we've got y minus y1 is 2. And that's equal to our slope, which is 4/3, times the quantity x minus x1 is 1. Now that is our equation, but I'm going to clean that up. So I'm going to distribute my 4/3, and I'm going to bring it up over here. I've got y minus 2 is equal to, if I distribute my 4/3, 4/3 times x is 4/3 x. And 4/3 times minus 1 is minus 4/3. Now I want to isolate my y, so I'm going to add 2 to both sides. And I've got y equals 4/3 x minus 4/3 plus, I'm going to make that 2 into a fraction because I know to combine it with the minus 4/3, I need a common denominator. So the common denominator there will be 3. So now I have y equals 4/3 x minus 4/3 plus 6/3. Combine your numerators as you now have a like denominator. -4 and plus 6 is a positive 2. So we've got as a final answer y equals 4/3 x plus 2/3 as our final answer. All right, let's look at this example. Find the equation of the line that passes through the points -3, 4 and -2, -5. This is exactly the same as the problem we just did. We're given 2 points. We'll let one be x1, y1 and the second be x2, y2. We're going to find the slope first by finding y2 minus y1 over x2 minus x1. Plug those values in, we get -5 minus 4 divided by x2 minus x1 will be -2 minus a -3. Be careful of all those negatives. Clean that up. -5 minus 4 is -9. -2 minus a -3 is the same as adding a positive. So -2 plus 3 is 1. And -9 divided by 1, of course, is -9. And again, that's our slope value. So now we have a slope and we have a point. We actually have 2 points. You can use either. Okay. Now we're going to use y minus y1 is 4 is equal to our slope, which is -9, times the quantity x minus x1, which is -3. And clean that up. We've got y minus 4 is equal to -9 times x plus 3. Double negative is a positive. Distribute the -9. Y minus 4 is equal to -9x minus 27. And add 4 to both sides to get the final answer in slope-intercept form. Y is equal to -9x minus Minus 27 plus 4 leaves you with a minus 23. But what if the equation is given in standard form? Can you put the equation in slope-intercept form, or vice versa if you're asked to? And the answer is sure. You're just going to use algebra and rearrange the terms, and we've already been doing much of that. So for example, let's say the problem you're working on asks you to put the following equation into slope-intercept form, then determine the slope and y-intercept. Now this equation is given to you in standard form. The x and y are on one side and the constants on the other side. So slope-intercept form says solve it for y, isolate the y. So if we subtract 2x from both sides, we now have 3y is equal to 6 minus 2x, or negative 2x plus 6 if you, strictly speaking, want it to look like y equals mx plus b, which means your x term is written first. It does not matter, though. Okay? Now we want to solve for y, so we're going to divide each and every term by 3. What you do to one side, you have to do to the other side. And clean that up. We've got y is equal to negative 2/3 x plus 2. If y is equal to negative 2/3 x plus 2, and we're comparing it to y equals mx plus b, we know that m, of course, is the slope, so the number attached to the x is our slope. Slope is equal to negative 2/3. B is our y-intercept. So if b is our y-intercept in this particular example, we can see that b is a positive 2. So we have our equation, y equals negative 2/3 x plus 2. We have our slope, that's negative 2/3. And we have our y-intercept, which is a positive 2. Let's look at a couple more examples. Put the following equation into slope-intercept form, then determine the slope and the y-intercept of 1/4 x minus 1/2 y equals 5. Now, there are a couple of ways you could work this problem. One is you could move stuff around with the fractions, and that would be fine. Okay? An alternative way for those of you who really despise fractions is you can clear fractions in any equation, as we did in a previous module. So because that's good review, I think that's what I'm going to do. I'm going to take that equation and get rid of the fractions by looking at the denominators, a 4 and a 2, determining the least common multiple, or what would be the least common denominator if that's what we were doing. In this case, that would be 4, and multiplying each and every term by 4. So I'm going to multiply every term by 4 to clear fractions. So I've got 4 times 1/4 x minus 4 times 1/2 y is equal to 4 times 5. Again, this is not the only way to do this problem. You can work with the fractions if you want. Remember that those 4's can be written as fractions to emphasize that this is fraction work. 4 cancels with the 4. 4 divided by 4 leaves you with a bunch of 1's. Here, if you take a 2 out, 2 divided by 2 is 1. 4 divided by 2 leaves you with a 2. And now you're left with 1 times x is x, minus 2 times y is 2y, and that's equal to 4 times 5 is 20. We're trying to isolate the y, so we're going to subtract x from both sides. That's going to leave us with negative 2y is equal to negative x plus 20, or 20 minus x. Now we're going to take that and we're going to rewrite it so that I can then divide each and every term by negative 2. So we get y is equal to, negative divided by negative is a positive, and x over 2 is the same as 1/2 times x. You can pull that x out separate from that fraction. 1/2 x plus 20 divided by negative 2 is minus 10. So there's our equation in slope-intercept form. Now to identify the slope and the y-intercept, it's very easy. Slope is always what's attached to the x, so slope is 1/2. And your y-intercept is the constant that's at the end. Okay? In this case, your y-intercept is -10. Put the following equation into slope-intercept form, then determine the slope and the y-intercept. 2y = 8. All right, y-intercept form. Y = mx plus b. We want to isolate the y just like before. So divide both sides by 2. And we've got y = 4. Now if you compare that to this, the y equals, of course, directly compares. And then we do have a constant for our b, +4. Notice that there is not an x variable in this equation, but to put it in slope-intercept form, if you want that x to appear, you can simply put a 0 in as a coefficient, because 0 times anything is just 0. And so really 0 times x is gone. So it's still y = 4. But written like this, you can do a direct comparison just like before. Notice that the slope then is 0. And the y-intercept, or the b, is a +4. So we've got y = 4 in slope-intercept form. Slope is equal to 0 for this line. And the y-intercept is equal to a +4. All right, put the following equation into standard form. Now, standard form, remember, is ax plus by = c, where the x and the y variable are on one side of the equality and the constant is on the other. Strictly speaking, a and b should not be fractions, but should be whole numbers, okay, or integer numbers. So we are going to put x and y on one side and our constant on the other. It's also good form to let the a value be positive. So if that is something that will control which side you want to move your variables and constants around to, that's something to consider. So notice that my 5 is positive with my x term on the right-hand side. So I'm going to put x and y on the right and my constant on the left initially. So I'm going to move my y. I'm going to subtract y. That gives me 0 is equal to 5x minus 8 minus y. Now notice I have my x and y on one side. I want to move my constant to the other, so I'm going to add 8 to both sides. And now I have 8 is equal to 5x minus y. That is standard form. If you really want the x and the y to be on the left, though, you can just flip the entire equation around and rewrite it 5x minus y is equal to 8. Same thing, I just flipped the equation over. That is considered standard form. The second equation asks you to do the same thing, put the equation in standard form. This is just a one-step process. I just need to move the 6y, which gives me 2x minus 6y is equal to 7. X and y on one side, constant on the other. And there you have that same equation written in standard form. Turns out that if you know the slope and the y-intercept of an equation, then you can easily graph that line by doing the following. Your first step is you're going to find the y-intercept and plot the y-intercept on your graph. Again, y-intercept is the point where your graph crosses the y-axis. Second step, starting at the y-intercept, count your slope and plot a second point. Now you have 2 points on your graph. You can draw a line through your 2 points and you'll have your line. And let's demonstrate all 3 of those steps with an example. The question is, graph the equation y = 3/4 x plus 3. First thing you want to note is this is slope-intercept form. Y = mx plus b. So immediately you can pull out your slope which is 3/4, and your y-intercept, which in this case is a +3, or ordered pairwise is going to be 0, 3. Okay, now following the steps listed above, your first step, once you determine your slope and your y-intercept, is to plot the y-intercept on your graph. So our y-intercept is 0 left or right and 3 up. So coming over here, 0 left or right and 3 up will be right there. Okay, now we're going to count slope, and this is something we haven't done in this direction. Before we had the line already drawn and we counted slope from that. Now we're going to do the reverse. Remember that slope is always rise over run, or it's the change in y values over the change in x values if you like that better. So for this particular problem, we have a +3, sign is important too, a +3 change in y value. Okay? +3y in terms of direction, okay, your y-axis you know is either up movement or down movement. So a +3y implies you're going to move up 3. The denominator of this slope, which is a +4x or a +4 run, +4x values imply you're going to move 4 units. And if it's positive and you're talking about the x-axis, x movement is either right or left. If it's a positive value, you're going to move right. So that's true for any point on the line. If you have a line and you have one starting point, if you go up 3 and right 4, that's going to be another point on the line. And if you went up another 3 and right another 4, that would be yet another point. So we already have our point to start. We've got our y-intercept. So from there, we're going to go up 3. So that's 1, 2, 3. And we're going to go right 4. 1, 2, 3, 4. And that's a second point on our line. Okay? So we went up 3 and we went right 4. Connect the dots. And if you want to label that second point that you just got by counting slope, you can just look at your x and y axis. From our x-axis, we can see that we went to the right 4, and our y-coordinate is a +6. So 4, 6. All right, let's do a couple more examples. Graph the equation y equals -4x minus 1. This is y equals mx plus b. So our slope is -4, or -4/1, since we have to count slope. You can take any number, throw it over 1, now it's a fraction. Okay, b, make sure you carry the sign. b is a -1, that's our y-intercept. And so the ordered pair there would be 0, -1. So 0, -1 is going to be your starting point. Coming over here, 0 left or right and 1 down is right there. That's 0, -1. Now let's look at our slope. Remember that slope is change in y over change in x, or rise over run. So we've got a -4 change in y. -4y implies we're going to move 4 units down. Negative means down if you're talking about y values. And we've got a +1x. +1x implies 1 unit to the right. So from our y-intercept, we're going to move 4 down and 1 right. So from here, we're going to go 1, 2, 3, 4 down, and 1 right is right there. Connect the dots, and there you have a sketch of your graph. This ordered pair right here is 1 to the right and 5 down. This ordered pair right here was our y-intercept, 0, -1. All right? Let's do this example. y equals mx plus b. There should be an x in that equation. I apologize, I missed that. So we've got y equals negative 1/4 x plus 5. So here our slope is negative 1/4, and our b is 5. Let's start with our y-intercept. Y-intercept then for ordered pairs will be 0, 5. So 0 left or right and 5 up will take us 5 up from the origin, and that'll be right here. Okay, now from there, if you have a negative fraction, you have to decide whether you want to put the negative sign up in the numerator or down in the denominator. So since I personally prefer to just leave negative signs up in the numerator, that's what I'm going to do. Okay? So remember, slope is always change in y values over change in x. So here we've got a change of negative 1y. That implies you're going to move 1 unit down. At the same time, we have a positive 4x. That implies you're going to move 4 units to the right. All right, so from that ordered pair that I have listed already, we're going to move 1 down and 4 to the right, 1 down and 1, 2, 3, 4 to the right. Puts us right there. Okay, we'll label our points. Our y-intercept was 0, 5. And our second point that we got is going to be 4 to the right and 4 up, it looks like. 4 to the right and 1, 2, 3, 4 up. And there you go. What if the equation is given in standard form and you were asked to graph? Well, you might recall in an earlier section we did just that. So you already know one method. When you have an equation, any kind of an equation, the first method to graphing that equation is you can take the equation in any form, find at least 2 ordered pairs that are solutions, plot those points on your graph, and sketch your line through those points. Okay? And again, that also works with slope-intercept. If you prefer just to get 2 or 3 ordered pairs by plugging in an x and solving for y or vice versa, and then plotting those points, that still works. What you learned prior to this is still valid. But now you also know a second method. You can take any equation, and if it's not in slope-intercept form, you can rearrange it into slope-intercept form, find the slope and the y-intercept, and graph the line as we just did in the examples where you plot the y-intercept and then count slope to get a second point. So you now know 2 methods for graphing any linear system. So let's graph 3x minus 5y equals 15 using both methods to make sure we get the same graph. So the first method is the method that you knew prior to this section, and that is to take the equation in any form, get at least 2 ordered pairs. 3 is always better for a checkpoint. Plot those points, draw your line, there you have it. So for this equation, I'm going to choose to let x be 0 as my first point. Remember, you can choose any x and solve for y, or choose any y and solve for x. So if x is 0, this equation becomes 3 times 0 minus 5 times y equals 15. 3 times 0 is 0. 0 minus 5y is just minus 5y equals 15. Divide both sides by negative 5, and we find that our first point is y equals negative 3 when x is 0. Okay, we need at least one other point. So now I'm going to choose to let y be 0, just because I think the math is easy. So if I let y be 0 for my second point, I get 3x minus 5 times 0 equals 15. 5 times 0 is 0. So now I've got 3x equals 15, or if I divide both sides by 3, x is equal to 5. So when y is 0, x is 5. And let's just go with those 2 points since we have a second method to check it with. Our first point, 0, negative 3, is 0 left or right and 3 down. So 0 left or right and 1, 2, 3 down. It's down here. And then our second point is 5 to the right and 0 up or down. So 5 to the right and 0 up or down is right there. Okay, so if we sketch that line in as best I can, that looks pretty close. I kind of missed that y-intercept point, but bear with me. All right, now we're going to take that same equation. We're going to rearrange it into slope-intercept form, and we're going to graph it using the y-intercept and counting slope. So we've got 3x minus 5y equals 15. I want to solve it for y. So I'm going to move the term that has nothing to do with the y. I'm going to move that 3x first. So subtract 3x from both sides. That leaves me with negative 5y on the left-hand side. Now the right-hand side, 15 and 3x, they're unlike terms, so you can't combine them. But I'm going to write the x term first just so I can have mx plus b form. So I've got negative 3x, I'm writing that term first, and then plus 15, I'll write that one separate. Okay, now I'm trying to solve for y, so I have to divide each and every term by negative 5 and clean that up. That gives us y equals negative 3 divided by negative 5 is a positive 3/5. And I'm going to write that x separate. Remember, we talked about it being okay to pull that out behind if that x is in the numerator. And then here we've got plus 15 divided by negative 5. 15 divided by negative 5 is a minus 3, or plus a negative 3 if you like that better. Y equals 3/5 x minus 3 is y equals mx plus b form, where m is 3/5 and b, or our y-intercept, is negative 3, so the ordered pair there would be 0, negative 3. So our first step using this method is we always plotted the y-intercept first as our starting point. So 0, negative 3, note that that is one of the same points that I picked when I was randomly choosing points. So that's going to be our starting point. Okay? Doesn't matter whether you got that point on the first one or not, but the point that we picked should lie on the line somewhere. Now we're going to count slope. Okay? Remember, slope is change in y over change in x. So what we have here, if we bring it up here, is we have a positive 3y, which implies in terms of movement 3 up. And then we've got a positive 5x, which implies movement 5 to the right. So from the y-intercept, we're going to go up 3, 1, 2, 3, and we're going to go right 5, 1, 2, 3, 4, 5. Happens to be the very same point. Okay? Looks good. Both methods give us the same line. All right, so let's do the same thing with this problem. 2x plus 3y equals 6. Okay, our first step, if we're using the method that we learned in previous sections, is just to pick an x and solve for y, pick a y and solve for x, get a couple of points and graph those. Okay, and for this problem, I'm going to choose points other than intercepts, just so maybe we can get a couple of different points with both methods and see that you end up getting the same line. So let's say, for example, I decided to let x be 6, we'll say. So that gives me here, if I let x be 6, I get 2 times 6 plus 3y equals 6, or 12 plus 3y equals 6. Trying to solve for y, so subtract 12 from both sides. I've got 3y is equal to negative 6. 6 minus 12 is negative 6. Divide both sides by 3, and I find that y equals negative 6 divided by 3, which is negative 2. That's one point. In addition to that, I'm going to choose another x value, I think. I'm going to let x be equal to, let's say, negative 3. Okay, I'm going to let x be negative 3. So now I've got 2 times negative 3 plus 3y equals 6. That gives me negative 6 plus 3y equals 6. Trying to solve for y, so I'm going to add 6 to both sides. That gives me 3y is equal to 12. And if I divide both sides by 3, y is equal to 4. So when x is negative 3, I found for this equation y is equal to 4. So let's plot those points. 6, negative 2 would be 6 to the right and 2 down. So 6 to the right and 2 down puts us right there. And the second point for this particular equation is negative 3, 4. So that's 3 to the left and 4 up. So 3 to the left and 1, 2, 3, 4 up is right there. 3 to the left and 4 up. Go ahead and draw in your line. And that's our line using method 1. Let's see if we get the same line using method 2. Okay. We're going to take the equation, 2x plus 3y equals 6, and we're going to rearrange it and get it in slope-intercept form. So move the 2x, subtract 2x from both sides. That gives us 3y equals negative 2x plus 6. I decided to write my x term first, carry the sign. Divide everything by 3 to get that 3 isolated. And we get y equals negative 2/3 x plus 2, where we can see our slope is negative 2/3, and our b value, or our y-intercept, is positive 2, which is the same as 0, 2 in ordered pair notation. Okay, so 0, 2 is going to be our starting point. So 0 left or right and 2 up. Had I drawn that line straight, I think that line would have gone right through that point. So I do believe that 0, 2 is on that line. If you did it on graph paper in front of you and used a straight edge, you would see that that also goes through 0, 2. All right, now our slope is always going to be change in y values over change in x values. So a negative 2y implies you're going to move 2 down, and a positive 3x is going to tell you to move 3 to the right. So from our y-intercept, I want to move 2 down and 3 to the right. So from here, I'm going to move 1, 2 down, and 1, 2, 3 to the right. Yep, that point's on the line as well. If I sketched that in, I'd have the exact same line. All right, so you now know this is the end of Module 9, Section 3.5 material, and this is also the last video for Module 9. You should now complete the homework for Section 3.5 in My Math Lab. When you have successfully completed that homework, review all the material for Module 9 and complete the Module 9 exam, also found in My Math Lab. After successfully completing the Module 9 exam, you may proceed to the Module 10 videos.